Okay, so this is for the law of cosines. You can use it for any triangle. It does not have to be a right triangle. And you're going to see our law next. So here we go. So we have our law of cosines here. And you can see that we have options. It's not necessarily like you're going to be using all three of these. You could use this one or this one or this one, all depending on either the angle you're searching for or the side length you're searching for. Essentially, your given information will determine which one you're going to be using. You won't be using all three, just one. Remember, just like with our law of sines, if we have angle A, that's across the triangle from side A. Same with angle B, it's across from side B, and C. So you need to be careful when setting this up that you're labeling the sides the correct length, because it will make a difference. And one thing to take note of is that if you look here where it has like cosine of A, the side length that's by itself is the corresponding side length, so A. And that's really going to help you remember how to set this up. It's your angle that you have in your cosine. That corresponding side length is the one that's isolated, the one that's by itself. So that's the correlation between what goes there and what side length is by itself. All right, so here's our first example for a law of cosines. You can see it's again not giving us a diagram, but giving us enough information to make one. So we're going to do that. Remember, it doesn't have to be a right triangle, so it can be, however you want it to look. They're telling us that it's triangle PQR, so you can pick anywhere to start and just make sure as you're going clockwise it follows the same order. Now, if you also want to label your side lengths, remember that like little letter P is going to be across from the angle P. So we have little p, little r, and a little q. Okay, and that's just letting us know what values are going to go where. Now we can pull those values from our problem. So P is 220. Q is 890. And we don't know about side R, but I do know that angle R is 121. Okay, we do want to make sure that we notice that this problem is asking us to round it to the nearest inch, so at the end we will be rounding our answer, but not until the very end. All right, so to get this set up correctly, we need to see what angle we actually have. So we have angle R, which is nice because we're also trying to find side R. So if we wanted to get this set up, just with letters, we would have R squared by itself, because I would want my cosine to be containing my angle R. So that means that I'm going to be adding, and I'm going to have it doesn't matter if you do your P or your Q. So we'd have P squared plus Q squared, and then we're going to subtract 2PQ. And that really follows, if you look at the past slide or if you have that on a note card, you can see that the angle that you have in your cosine should match the side length that you have by yourself. And then when you look at your other terms, it's just your other two sides, you fill them in where they belong. So similar to if this were A, an angle A, and then this was side B and C, and B and C. So let's fill in some values here. So we have, we have R squared. We don't know what R is, but we do know that P is 220. We know that Q is 890. So we can fill that in. We have another times 2 times 220 times 890. And then that is times cosine of my R, and my R was 121. Okay, so it's definitely a lot of algebra at this point because we just have to make sure we're squaring appropriately, multiplying appropriately, and finding the cosine. So we would have R squared equals, when we square 220, we get 48,400. When we square 890, we get 792,100. Now notice that I didn't do any sort of multiplication to that. I'm just squaring those values. Now I can multiply 2 times 220 times 890. And I get negative, or sorry, I have a minus here already, so it's 360,800. And then times cosine of 121. We'll fill that in the next step. So far I just handled all the values. Now we'll have r squared equals. We can combine these first two, they're just being added. So if you want to add those, you can get 840,500. And we're going to be subtracting a negative 185,825.7374. So I just used a calculator, found the cosine of 121, and multiplied it by the value in front of it. Now we can combine these. So we have r squared to equal. When we combine them, this actually becomes addition. So this becomes 1026,325.737. So this is the value for r squared. We want r by itself, so we're going to take the square root of both sides. When you do, you get r to equal 1013.07736. So this is like the exact amount. Our problem here, or whatever problem you might be working on, might ask you to round, and this one asks you to round to the nearest whole inch. So we would round down to 1013 inches. All right, so in this example, they're telling us that we have triangle STU, so we can actually just draw that. Remember, these don't have to be right triangles. It could be any shape. So we have STU, doesn't matter where you start, so we'll start here. Okay, they're telling us about our side lengths. They're telling us side length S is 50 inches, so notice I put that across from angle S. They're telling us side length T is 58 inches. That's across from angle T. And they're telling us side length U is 27 inches. All right, so the difference between this problem and the last one we did, the last one at least gave us a value for an angle and then asked us to find a side length. This problem is totally different because they're giving us 3 side lengths. They're giving us all of the side lengths, and we're trying to find the measure of angle S, okay? So we still are going to use this law of cosines, but in a different way here. So if I'm trying to find angle S, that means that's the angle that's going to be in my cosine. So as I'm getting this set up, this is my right-hand side, I'm going to have cosine of S as the end of my little formula here. Now, because S is what's in the cosine, I know that S squared will be on the left-hand side all by itself. Okay, so that's the first steps for getting this set up. Whatever angle you have in the cosine is the side that's by itself. So then from there, we know that the other 2 sides are U and T, so we can do T squared plus U squared minus 2T U times cosine of S. So it doesn't matter if you did U squared plus T squared, if it in a different order, you're going to get the same answer. You just need to make sure that S is the one isolated. So now we can fill in our values here. We know that S is 50, so we have 50 squared equals T squared, so that's 58 squared, plus U squared, so that's 27 squared, minus 2 times 58 times 27 times the cosine of S. Okay, so just like with the last problem, we have a little bit of algebra to do to simplify. So we can rewrite 50 squared as 2,500. Then we have 58 squared, which is going to give us 3,364, plus 27 squared, which is going to give us 729. We can multiply 2 times 58 times 27, and we're going to get 3,132, and that's going to be multiplied by our cosine of S. So right now, we want to try to isolate that cosine of S. So to do that, we can add together our 3,364 and 729. So our next sign looks like 2,500 equals, we have 4093 minus 3132 cosine of s. So lots of big numbers in this problem. So pretending like cosine of s is some sort of variable that we're trying to isolate, first thing we're going to want to do is get that 4093 to the left-hand side. So we're going to subtract 4093. When we do, we get negative 1593 equals, and now we just have our negative 3132 times cosine of s. Okay, we have this negative 3132 multiplied, so we want to divide by negative 3132. Okay, and we're going to get a decimal here. The decimal is going to be fairly long. You don't want to cut it off yet, so we're going to have 0.508, 620, 6897. And that's going to equal the cosine of s. All right, so the problem here is that we need to get rid of this cosine now. So we've isolated it, but we need to know what angle that when we plug it into this cosine would give us 0.508, like this whole decimal. So what we need to do is the inverse of cosine. We need to basically undo it. So to do that, we'll take cosine to the -1 on both sides. And what that'll do is that's going to cancel out the cosine on your right-hand side, and it's also going to tell you what value will give you, what value of an angle will give you this as your cosine value. So we have cosine to the -1 of that decimal on our left-hand side equals cosine to the -1 of the cosine of s. Okay, so what you can think about, it's kind of like squaring a square root. It's going to cancel out. So on our left-hand side, you're going to be able to plug that right into a calculator. Okay, you would use your second menu, and then you would do second cosine to get the cosine to the -1, and then type in your 0.508, your whole decimal, don't cut it short. So this becomes 59.43 degrees. And my right-hand side, this cosine to the -1 and cosine cancel, so we're just left with the angle measure of s. This specific problem asks to the nearest tenth, so we'll just reduce this to 59.4 degrees.